In this screencast, we'll continue talking about minimalization, and let's continue talking about the sum of alpha products. So that we gave an example of sum of alpha products at the end of the previous screencast, and we defined the function g. Let's go through another example of that function g, which is the sum of the alpha products of a specific predicate. So let's say t naught is equal to 3 and y is equal to 1. Then g of 1, which is the value of y, is equal to the sum of u from u to y, which is 1, of products. T is equal to 0, u, so the product of t alpha of x1 through xn and that is equal to the product from 0 to 0 of alpha p t x1 through xn plus the product from 0 to 1 of alpha p of t, this is t, x1 through xn, and that's it. So, and since we haven't hit t naught yet, so it's 1 plus 1. So these two examples at the end of the previous screencast on minimalization and this example with G allow us to prove a simple lemma, or an observation rather. So if t0 is the minimal value of t for which b t x1 through xn is equal to 1, then for all y less than t naught, g of y x1 through xn, the sum of alpha products, let's is equal to y plus 1. Alright, let me separate it, otherwise it looks confusing on the board. So the proof is pretty straightforward. So y is less than t naught, then we have for all u in this interval y from 0 to y, well, we assume that t naught is greater than 0. So the product of alphas from 0 to u, pt x1 through xn, is equal to 1. So since that interval y from 0 to y, closed interval, has y plus 1 elements, so again we assume that y is at least 0. Well, otherwise it's a trivial case of summing from 0 to 0. Has y plus 1 elements, then g of y x1 through xn is equal to y plus 1. And this is the corollary, which is stated in Chapter 3 of Computability, Complexity, and Languages by Martin Davis, Ron Segal, and Elaine Weyuker. So if t naught is less than or equal to y, then g of y x1 through xn is equal to the sum of from u equal to 0 to y, products from t 0 to u of alpha pt x1 through xn is equal to the value of u less than t naught, the sum of u less than t naught of 1, which is the value of t naught. And now that we have g, and we have defined it in terms of as the sum of the alpha products, so we can use g to define the bounded minimalization of the predicate p. And the bounded minimalization is equal to the value of gy x1 through xn if there exists a t less than or equal to y for which pt x1 through xn is equal to 1. Otherwise, it gets the default value of 0.